That means if m dx and dy is equal to 0 is not exact, m dx and dy is equal to 0 is not exact. Now we will find del m by del y minus del n by del x. Del m by del y minus del n by del x. Okay, till this step all equal. But if we multiply with 1 by n, that means if we divide by n, we can say that multiply with 1 by n, and if we get function of x only, okay, compulsory function of x only, no y is here, okay, no y should be there, only function of x, then if is e raised to integration f of x dx. And if we multiply this with 1 by n, and if we get y also, then this is not possible, so we will multiply with minus 1 by m, that means this. And if we get function of y only, then if is e raised to integration f of y dy. So this is the difference only. Divide by n, and that divide by n, so must be in the function of x only, and divide by minus m, that function should be compulsory y only. This is the difference. Okay, so let's understand both the method by one example. Okay, so first example, solve this m dx plus n dy is equal to 0. So you say equation number 1, that this is our m, this is our n, differentiate m partially with respect to y, differentiate n partially with respect to x. So we have this two derivative, and you can see that this is minus 4mxy and this is 4mxy. Both are not equal, that means given differential equation is not exact. Now if it is not exact, then what? Then now we will first check, is method number 1 is applicable, that means given differential equation is homogeneous? No, so method 1 is not there. Number 2, function of xy and y dx, x dy, anything is there? No. So method number 2 is not possible. Now we'll think about method number 3 and 4. In 3 and 4, what we should do, that we have to find the difference del m by del y minus del n by del x. So first we will find del m by del y minus del n by del x. That means minus of 4mxy minus 4mxy. Okay, so we have minus 8mxy. Now think by which term we will divide, we get the function of x only or y only. So if we divide this minus 8mxy with this term, if we divide with this term, not possible to simplify, okay, because of two term in denominator. Okay, so divide by m is not possible, it is clearly seen here. So we will try with this n. So if we divide this with n, that means we have this, so y cancel out, mm cancel out, and x1 cancel out, and this is our 4. So we have minus 4 by x, and this is a function of x, and as we told, this is our n, and if we divide by n, and if we have a function of x only, it is good, it is method number 3. Okay, so we have this, and we will divide this by 1 by n. This is our n. Okay, so we will divide by 1 by multiply by 1 by n. So by simplifying, it is a function of x only. And if it is a function of x only, this is not our if. Now if will be e raised to integration f of x dx. F of x is minus 4 by x. So minus 4 as it is, and 1 by x, integration of 1 by x is log x. Now we can take this minus 4 in this power. So we have e raised to ln x is to minus 4, and we know that e raised to log x gives us x only. So e raised to log x is to minus 4 is equal to x is to minus 4, which is equal to 1 upon x is to 4. This is our if. Now after finding if, we know the method. Multiply equation 1, that means original question. Okay, so multiply equation 1, this one, by if So we will multiply 1 by if, 1 by x raised to 4. Okay, so by simplifying this, we have this term, and this become compulsory exact. This become exact. And if it is exact, then solution is given by integration of this term, keeping y constant, and integration of this term free from x. But here in this, x is included, so we have to omit this entire term. Some say, sir, we have to just ignore this x only. No, we have to take term free from x. This is the only one term which contain x, therefore we have to omit this entire term. So we'll take 0 instead of that. So this becomes 0 dy. Now integrating with respect to x, so integration of e raised to x, e raised to x, this is constant, and integration of 1 upon x cube, same process as I told, x raised to minus 3, and integration of this is x raised to minus 2 by minus 2, and we can write minus 1 by 2x squared. So we'll use that. Okay, and by cancel out this 2 and minus minus plus, and this is 0 and c. So by simplifying this is our general solution. Okay, similar way, I'm just taking one more example. Okay, so you can understand method number 4. That means how that minus 1 by m multiply will give the answer. So we have one example. Solve y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 minus 4x dy is equal to 0. Okay, so now first we will start with the that m is y raised to 4 plus 2y, and what is n is xy cube plus 2y raised to 4 minus. So this is our m and this is our n. Now we differentiate m with respect to y partially. So we have 4y cube plus 2, and if we differentiate n partially with respect to x, so y cube constant, differentiation of x is 1, differentiation of this 2y raised to 4 is 0, and which is minus 4. Okay, differentiation of this. So here we can see that del m by del y, which is not equal to del n by del x. So therefore, given differential equation is not exact. Equation not exact. It is not exact. Now we have to check that method number 1, method number 2 is possible, but it is not homogeneous, as well as it is not in the form of that xy and y dx wala. Okay, so we will find the difference of these two terms. Okay, that means we will find del m by del y minus del n by del x, and then we will decide that rather n or m is suitable for division. Okay, so we have del m by del y is 4y cube plus 2, 4y cube plus 2 minus del n by del x is y cube minus 4. So by opening this bracket, expanding this bracket, 4y cube plus 2 minus y cube plus 4. So we have 3y cube plus 6. Okay. Now think about m and n. By which term, if we multiply, then we will get the correct answer. So now if we multiply this 3y square y cube plus 6 by n, so we have this is n, and because of this, not possible to get the answer in the form of in the function of x only. So we'll think about this, and this is the y only. So if we take y from this, so we have y cube plus 2, which can help us. So we will multiply with 1 by m, but as I told, whenever we will use 1 by m, we'll put minus, because formula is that. Okay, so we have this, and we have minus 1 by y raised to 4y cube, that one is y raised to 4 plus 2y, and this is our, if we take 3 outside, y cube plus 2. Now if we take outside, so minus 3 y cube plus 2, and if we take y from the denominator, so y cube plus 2 By cancel out this 2, we have minus 3 by y, which is a function of y only. Yes, this is the function of y only. Okay, so by multiplying minus 1 by m, we have a function of y only. So we have if is equal to e raised to integration f of y dy. So integration minus 3 by y dy. Okay, so e raised to minus 3 as it is, and 1 by y is log y, and which is equal to e raised to log y raised to minus 3. So we have y raised to minus 3, that means 1 upon y cube. Now we will multiply if with equation number 1. That means our question. So we have 1 by y cube. What is our question? Y raised to 4 plus 2y. Ready? And dx plus 1 by y cube. And what is n? N is x y cube plus 2y raised to 4 minus 4x dy is equal to 0. So if we simplify this bracket, we have y plus 2 by y square dx, and if we simplify this to x plus 2y, because we are multiplying 1 by y cube in this bracket, minus 4x by y cube dy is equal to 0. So now this equation become exact. Okay, and therefore the solution is, as I told, whenever we are integrating with respect to x, we'll take entire term. So we have this entire term, but when we integrate with respect to y, term free from x, so this and this both term omitted, so we have 2y dy is equal to c. By integrating with respect to x, so we have to just multiply x, because this 2y square and y constant, and we have this y square by 2, so to cancel out, y square is equal to c. This is our general solution. So now you know how to check or how to find if. Okay, so this is the method how we can solve this entire example. Okay, now these are the some example for you that you can solve by yourself. Okay, and which will help you to solve or to understand next lectures. Okay, so these are your 4 example, which is based on method number 3 and method number 4. And which example is of method number 3 and which example of from method number 4, that will understand by solving the example only. So after finding del m by del y minus del n by del x, you have to just try and check that by dividing m minus m or by dividing n, you will get the function of y only or x only. Okay, so this is the method. Okay, so please try to solve this example. This will help you for the next lecture, for the lectures and in examination. So thank you for watching today's lecture. We will see you soon with next lecture